Hello students. So today we're going to be talking about cloud formation. As you can see up there, our learning target is I can explain how clouds form. There's a couple of things we're going to talk about, but that's the main one. So here's a nice picture of a lenticular cloud up in the mountains. We're actually not going to talk about a lot of these weird, kind of spooky looking clouds. And there's a lot of different weird clouds out there if you want to ever look them up, but we're kind of focusing on the main ones and how they form today. So a bit of a recap. Now, it's all in italics, so you don't need to write any of this down. Dew point is when the air is full of water vapor, temperature drops, water vapor condenses to liquid. That temperature at which it condenses is the dew point. You can have lots of water vapor in the air, and that's why we find dew forming in the morning, or it has formed in the morning, because there's enough water vapor in the air, and as the temperature drops overnight, keeps dropping, 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 if it dips below that dew point, that's when the dew starts to form. All that water has lost enough energy to condense onto things that are colder than that. So they just cling to it, and that's why we get this dewy grass. Of course, the sun comes out, and the dew kind of evaporates once again. But yeah, again, the temperature at which water condenses is the dew point. So again, you got some italicized stuff here. Dew needs a surface to condense upon. You need some kind of solid surface, something for it to condense on. It could be grass, car windows, outside of a tent, etc. So lots of things could be that. And generally, solid objects are going to be quicker to kind of soak up that energy or kind of be colder, feel colder for the water vapor to condense upon or to cling to. I just gave some examples right here. Clouds. So write the word clouds. We're kind of start talking about them now. Now we're done with the recap. Clouds form when water vapor condenses into droplets or ice crystals. So technically, ice crystals would be formed by the process of deposition because it's one molecule at a time condensing or freezing one molecule at a time on there. That's how we get frost as well. But clouds form when water vapor condenses into droplets or kind of turns into ice crystals high up in the sky. You got some interesting mammatus clouds right there. More about those later. Please write this down. 3 things are needed to form a cloud. Right down there. And I'm going to give you the 3, obviously. There are 3 ingredients for making clouds, and we'll try this in class. The first ingredient is water vapor. And you can see in this nice picture, you've got some birds. I think those are ducks. And there's a lake in the morning, and the sun's coming over the trees, and it's putting enough energy on the surface part of water, and it's actually creating some steam. Clouds are made up of water, so water vapor is required. It's kind of a no-brainer, but it's worth writing down. You need water vapor to make a cloud. Next slide. The second need, particle, some kind of surface to condense upon. So we're not talking about a tent or a shoe or a window or something like that. We're talking about clouds. So there has to be something high up in the atmosphere for water vapor to condense upon. It could be dust particles, it could be pollen, it could be a very fine piece of volcanic ash. It doesn't really matter as long as there's some very small object. I mean, it could be bigger, but obviously, if it's a heavier object, it's going to get a little bit of water vapor condensed on it and fall straight down. We need a very small object. They call it a condensation nucleus or nuclei. So you've got a little tiny particle, a very small microscopic particle that all of a sudden water vapor can condense upon, and it basically starts building up into these water droplets, or if it's high enough in the atmosphere, ice crystals, very fine ice crystals. So I wrote here, just need something to condense upon. You got a bee here, obviously spreading pollen around. And anybody with allergies knows what it's like. That pollen is everywhere, and it's very small. Each particle is very small. And the third ingredient is cooling. Now, it's not really an ingredient, but it's a factor, right? So cooling, there's some level of cooling has to happen. So the temperature was one spot, and then it dropped down. Well, particles drift all the way up into the atmosphere, you know? If an air mass, a small air mass with a lot of water vapor, goes up into the atmosphere higher, the temperature is going to drop. One, because it's further away from the surface and less things that radiate heat. 2, the atmosphere is thinner, so it's going to be, decreasing in temperature, or at least that ability to hold on to the temperature. And 3, if you go high into the atmosphere, you're reducing the pressure, which also causes cooling. It's just a matter of the chemistry of it. When you quickly reduce the temperature or the pressure of something, it loses energy. So the air needs to cool, it loses energy, a decrease in pressure also causes cooling. I've got some interesting clouds, and I believe these clouds are formed usually most often off the coast of Australia. And I can't remember the reason, but they create these weird ropes. More on that, I guess, another time. So now let's get to the main cloud types. Please write this as a heading. You've got this right there, the heading right there. Main cloud types. And I'm just going to move right ahead because I'm not waiting for people to write. Fog. We don't need these all in separate lines. You can put fog information on one single line. Just write fog nice and bold and underline it. Fog forms near the ground. Forms often after humid days. And so it's a cloud low at the ground. I live next to the Mississippi River Valley, and a lot of times when I'm driving over the Smith Avenue Bridge, I can see a nice little layer of fog down by the river, and I'm kind of driving above. And it always has this cool feeling like I'm driving over the clouds, but we all know it's just a bridge over a river valley. The next, these are ones we see a lot. Cirrus clouds. Cirrus clouds are faint and feathery. You can see a picture right there. They're kind of stringy. They're made up of ice crystals, and they form really high up in the sky. Obviously, higher in the sky is going to be much colder, so they're not going to turn into water droplets. They're going to form ice crystals. They're very faint and feathery because those solid crystals kind of just drift around. They're not going to turn into rain. They're just going to be drifting around. The energy from the sunlight might actually make those ice crystals evaporate or almost sublimate up into the sky, but those are up in the sky. These often indicate fair weather and sometimes can tell of an incoming warm front, which we talked about the other day. Cumulus clouds. These are the classic ones that everybody draws. Cumulus clouds, cotton ball, they're large, cotton ball, fluffy. A lot of times they're moving quickly because they're fair weather, or they can indicate a change. If it's breezy and you see these guys floating around, it's often meaning that you're kind of in between some air masses and the weather might be changing after a bit. They're made up of nice big water droplets. They form under 2 kilometers from the surface, so that's under a mile. So relatively low in the sky. And like I said, they indicate fair weather. These are our classic clouds, though. They're so cool when you see them moving fast. They're big and they seem really low in the sky. Cumulonimbus. I got a phonetic spelling up there. Cumulonimbus. Massive cotton ball. They're very tall if you can see them from a distance. They reach all the way up to the stratosphere, and that's why they have that flat top. I've mentioned that before. They're made of water droplets, and these clouds often form in the edges of cold fronts. And it's because of that vertical development. The cold front is coming in, it pushes that warm air straight up really quickly, and you've got that vertical development. These cause hailstorms, can cause thunderstorms, can cause tornadoes, a lot of stuff like this, depending on the different ingredients in the atmosphere at the time. But these are the big boys that cause a lot of storms, and big storms. And I know I'm going fast, but we can also pause and go back when we're on a video. Stratus clouds are our last type. Flat layer of gray. If you ever see it looks like a gloomy day, that's stratus clouds. Stratus clouds look gray because they're blocking out some of that sunlight, so it's going to be a little bit darker. They're made up of water droplets. They form at different heights depending on the conditions and everything. They indicate it's cloudy or sometimes rainy weather. And nimbostratus clouds which are basically our rain clouds. When you've got a warm front and it's just kind of like a drizzly, rainy day, that's straight up a nimbostratus cloud, right? It's going to happen for multiple hours. It's not super aggressive. It's just going to be rainy, sometimes on and off rain. There's many types of stratus clouds. You've got cirrostratus clouds or altostratus clouds or nimbostratus clouds or cumulostratus. A lot of different, stratus just means layer. And so any layer of clouds of type could be just some kind of stratus cloud, but it just means there's a flat layer kind of blanketing the sky a bit. The last thing I have up here is not notes. Don't write this, don't write this, don't write this, but just some words up here in case you're curious about it, like you know some Latin, some words here that kind of where these words come from. But I'm going to stop there, and these are the notes for the day. Please get them on page, I believe it's 35 is our next open one, but please get those notes in, and have a great day. Thanks. Bye.